Okay, welcome back to another exciting episode of Altairs for Dummies. In the last episode, we began programming the Altair using assembly language to output a simple A to the screen. In this episode, we're going to continue on with that lesson by printing a full sentence across the screen. So let's get started. First, of course, we have to turn on the Altair and do a hard reset. Then we have to, of course, I have to address my ROM in my serial card by setting the address to F8. Then I do an examine, and then I do a run. And there we go, we're at the prompt. Okay, let's review how to view what's in memory. We do a dump, 0 to 30. And that's how you can see what's currently in memory. And now we can start programming. Now the program is getting a little bit longer now because we're using a full sentence, so half of the program is just ASCII characters, so don't be intimidated. Let's just start programming it in. First we'll do an enter and start at 0. And the first command is a 21 and a 16 and a 00. BB 10 B6 02 CA 03 00 7E FE FF CA 0D 00 D3 11 23 C3 03 00 49 20 4C 49 4B 45 20 40 59 20 43 4D 50 55 54 45 52 0A 0D and FF. And that's it. Now let's do a dump and see if we entered everything correctly. We got 21 16 00 DB 10 E6 02 CA 0300 7E FE FF CA 0D 00 D3 1123 C3 03 00 49 20 4C 49 4B 45 20 4D 59 20 43 4F 4D 50 55 54 45 52 0A 0D and FF, and that's it. Now we're ready to execute, but what I'm going to do first here is clear the screen so we can see what prints. And we're going to do an execute 0. And there we go. I like my computer. That's it. A simple little program. Now let's go to the Excel spreadsheet and see how this is all accomplished. Okay, in this episode, I hope to simplify things for you by just telling you there's basically only two parts of this program. This first part right here is the retrieve status bit portion, where you check to see if the status bit, if the registry is ready to transmit data. If it isn't, it just keeps looping. If it is, it goes on down to the second part of this program, which is it grabs the letter and then prints it, outputs it to the serial transmit port. So let's walk through the whole thing and see how this goes. The first step here is a load register with the first letter. In this case, the registers we're loading is HL with the first address of the first letter. Well, the address is 0016. If we look down here at 0016, we got an ASCII character I. So the first thing that's going to be up here is an I. The program can start. First thing we always have to do is check the status, the receive status byte, retrieve the status byte. Check that to see if it is actually ready to transmit data. If it isn't ready, it goes back and checks again. If it is, it goes down here to move the contents of the HL register into the A register. And then we check to see if that's the FF, which we have set for our end statement, the end of the program. But it's not, it's the 49, which is the letter I. So we continue on to output that letter I to the serial port address 11, which is the transmit data register. Then we simply increment the HL register to the next letter, which in this case will be an ASCII character 20, which is a space, and jump back to address 003, where we're going to retrieve our status byte again from address 10, which is my status register. You have to check your serial card to know where your status register and control register, what address they are, and what address your transmit data register and receive data register are. There's going to be two addresses. You have to know what those are. And again, you have to know how your status byte is set up. It could be set up anyway. So you're looking for this transmit data register empty, and it could be any one of these bits. So you have to figure out where how your status byte is set up so that you can properly check the status, to see if the status register is empty. Then we move the space into the A register. We check that for our last character, which would be FF. It's not FF, so output it to the screen again. Increment H again, or HL again, and jump back to 3 and start this process all over until we get all the way down to doing a line feed and a carriage return, and finally our FF code. And once we move the FF into the A register, it compares to FF. If it is a 0, it jumps right back to here. So it just keeps rolling back here. OD, it just keeps jumping back to this one place. Now we could have easily sent it to a halt instruction or something else, but that's how this program was written. So hopefully this has cleared things up for you a little bit. There's only two portions: retrieve the status byte and print it out to the terminal. So that's it for now. Thanks for watching.